Hello, everyone. Okay, so the last program in chapter 6, I think this is the last program, is fishing game simulation. All right, so for this assignment, you will write a program that simulates a fishing game. In this game, a six-sided die is rolled to determine what the user has caught. Each possible item is worth a certain number of fishing points. The points will remain hidden until the user is finished fishing, and then a message is displayed congratulating the user, depending on the number of fishing points gained. Here are some suggestions for the game's design. Each round of the game is performed as an iteration of a loop that repeats as long as the player wants to fish for more items. At the beginning of each round, the program will ask the user whether or not he or she wants to continue fishing. The program simulates the rolling of a six-sided die, and we had to use the die class that was shown in code listing 6.14. Well, so if you didn't read the book, the die class, we actually use the die class in a couple of the programs. I think tossing coins that was a coin class. But then we'll open it. We'll figure out which programs we did. I forgot which ones. But then we've used the die class a couple of times. Okay. So where am I? Okay. So each item that can be caught is represented by a number generated from the die. For example, 1 for a huge fish, 2 for an old shoe, 3 for a little fish, and so on. Each item the user catches is worth a different amount of points. The loop keeps a running total of the user's fishing points. After the loop has finished, the total number of fishing points is displayed, along with a message that varies depending on the number of points earned. Okay. So basically, when I read this question, I had an idea in my mind, right? So we're going to try to implement this as best as we can, because I feel, although Tony Gadd is a good author and his questions are clear for the most part, sometimes I feel it can be mistaken for something else, right? But then we'll try to implement it as best as we can. The most important thing is we are trying to implement the concept. As long as we understand the concept, we're fine. We can change it if we get a different understanding of the question. As long as we understand it, understand the concept, that's all that matters, right? So, okay, so we know we're going to be using the die class, right? So let's, we've created a die class a couple of times, so let's go ahead and make a copy of it. So I'm going to open, okay, let's look for it here, Java. I'm going to open where I save the Java programs and go through chapter 6. I think we had a die class in one of these programs. I'm not sure which one. Dice? Yeah. In the dice game. So we have the die class here. So I'm going to open it and then save a copy as. Okay, so let's save as. And in the chapter 6 folder, I'm going to go ahead and create a new folder for this program, and it's called a game of. Oops, that's different. It's called fishing game. Just make sure. Sorry. Fishing game simulation. Okay, so in chapter 6, create a new folder and call it fishing game simulation. And then creates I'm going to save the die class in here first. Okay, so save it here as that. So now we have the die class saved in there, and our program that's going to test the class is also going to be saved in that same folder. As long as they're in the same folder, they should be able to see each other. Okay. If you save the class somewhere else, the die class somewhere else, you have to specify to this program where that die class is, so that they can find each other. Otherwise, if you save both files, the die class and the program itself, in the same folder, they should be able to find each other. All right. So let's go ahead and create a class for this program, and then we'll go to the die class back and forth to see if we need anything. So public class, I'm going to call this fishing game simulation, and then I'll create the main method. Okay, so let's see. Let's try to break this down or decipher it. All right, so you will write a program that simulates a fishing game. In this game, a 6-sided die is rolled to determine what the user has caught. All right, so let's see. Each round of the game is performed as an iteration. So let's basically start with these bullets, right? So each round of the game is performed as an iteration of a loop that repeats as long as the player wants to fish for more items, right? So we know we're going to have a loop, okay, in our program that's going to keep iterating as long as the user wants to fish for more items, right? So let's create a variable, a character variable that's going to represent yes or no, basically y or n, right? So let's go ahead and create a character variable. Let's call it continue fishing. Let's call it continue fishing, and let's set it to the character n, which basically n represents no, right? So let's set it to the character n, okay, for now, and then let's go ahead and create a loop, okay, that is going to keep iterating as long as continue fishing is, let's say, y for yes, okay. So yeah, let's do that first, and then we'll continue. So let's create a while loop and say that while, so let's say while continue fishing is equal to, I'm using double equals to compare. And if I use one equal, I'm assigning what's on the right to what's on the left. If I'm using double equals, I'm checking to see if what's on the right, I'm just checking to see if what's on the right is equal to what's on the left. And if what's on the right is equal to what's on the left, this whole condition here is going to, or this whole test expression here is going to result to true. Right, so while continue fishing is equal to y, right, then let's do what's in the loop. We haven't typed in anything yet, but we will. All right, so initially continue fishing is n, right? So we need to ask the user, right, something. But actually, the second bullet over here says at the beginning of each round, the program will ask the user whether or not he or she wants to continue fishing. Okay, so we know we're going to ask the user that, right? So since we're going to be asking the user, we have to use one of Java's features for accepting user inputs, right? So I'm going to choose to use this kind of class. We can use the JOption pane, but I'm just choosing to use this kind of class, right? So I'm going to go ahead to use this kind of class. We have to import the class so that this program can have access to it. So I'm going to import the scanner class java.util.scanner. I'm importing the scanner class located in the java.util package in the Java API. All right, so once we import the scanner, we need to go ahead and create an object from it so we can use that object to basically accept input. Accept input from a source, right? So I'm going to go ahead and declare a scanner object. Okay, create a scanner object. I'm going to call it keyboard, right? And I'm going to so this is just a class type variable that's going to reference a scanner object. Now I'm going to create a new scanner object in memory, and I'm going to pass in the source of input, and that source of input system.in represents the keyboard. Okay, so I'm basically reading from the keyboard, and this keyboard of class type variable is going to represent that that object. Okay. All right. So I've declared that object here. So now I can ask the user with the system.out.println statement here. System.out.println, and I'm going to say, do you want to? Well, you would think that when the game starts, it should just fish, right? But then let's for the very first statement, let's just ask the user, do you want to fish? Or let's just say, feel like fishing, right? With just a question mark, because the user can say no for the very first time. If they say yes, then we basically, you know, so basically they say yes, right? Then continue fishing was going to be y, right? And if it's y, what's in the loop is going to run. And then in the loop, we'll ask them, do you want to continue fishing, right? Because after the statement is run, only the loop is basically what's going to, this statement is just going to run one time, just the very first time. All right, so after we've asked the user, do you feel like fishing? Do you feel like fishing? All right, now we need to accept the inputs from the user, right? Because, well, first of all, I'm going to go ahead and call keyboard.next All right, so I'm going to call keyboard.next line here. Okay, keyboard.next line. Now, keyboard.next line is basically going to pop up some kind of text box, right? It's going to allow the user to type in something, and whatever the user types, it's going to be returned as a string. All right, so if the user types in yes, I can even be very specific in the string here and say that please type in Y for yes and N for no. Okay, so if they type in Y, right, Y is going to be returned as a string, right? So some users can be stubborn, right, and then type in, let's say, yes. Right? I mean, not stubborn per se, but then we want to basically create our program so that it handles even errors or things that weren't necessarily meant, but then they were correct. So the user can type in yes as a string. Yes is going to be returned as a string. Okay, yes is going to be returned as a string, but the thing is, we want to store the user's response in continue fission, which is declared as a character. A character variable can't store a string variable. But what happens is whatever the user types here is going to be returned as a string. So assuming the user types in yes, we don't want yes. We only want one character. A character can only store one character. So what we are going to do to this is basically get the character at position 0. For every string you have, every character in a string has an index or a position, or you can think of it as an index. The very first character has an index of 0, second character has an index of 1, third character has an index of 2, and so on and so forth. The very first character of every string has an index of 0. If you have something like this, this has an index of 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. So J has an index of 9. Just know that it starts at 0. So if we are getting the string from the user and also fetching the character at position 1, then we are fetching only one character here, and that character can be stored in that continue fission character because it's declared as a character and it can only store one character. So if we are fetching the first character over here, then that can be stored here. Okay. All right. This needs a semicolon. If the user also goes ahead to type in just Y, right, next line is going to return Y as a string and not as a character. But then if because of the the char at, okay, the char at, it's so initially if there wasn't char at there like this, then if the user types in Y, although it looks like a character, right, because next line always returns a string, it's going to return the Y as a string. But because of the character at position 0, this string here has only a position of 0. So it's going to basically take this Y, basically convert it to a character, or basically it's going to be a character. All right. It's going to get that character and then store it in continue fission. So this is what we want to do. Once it returns that character, we want to go ahead and store it in continue fission. So now we have the value for continue fission, and over here it says while continue fission is equal to yes, then do what's in the loop. If continue fission is not equal to yes or Y, then skip this loop, right? So that's the goal. Okay, so the user wants to continue fission, then we're going to do what's in the loop. So let's move on. It said at the beginning of each round, the program will ask the user whether or not he or she wants to continue fission. The program simulates the rolling of a 6-sided die. Okay, so the program simulates the rolling of, so that's where we now need our die class. Now we spent time actually creating this die class in the two programs which use the die class, and I believe the first one was a dice game. The second one was I think we used it a couple of times, but then at least you know that we use it in a dice game. And the dice game is part of the chapter 6 programs that I created. So if you go through that, you know how we created the dice game. If not, then go through the chapter 6 programs. One of them has the full die class that we implemented. We created and explained out, and basically I explained. So we'll go through that and you'll see how we created this. But just to go through it, this die class has two fields: number of sides and die value. Number of sides holds the number of sides of the die. So if the die, it's a 4-sided, die, then it will be a 4-sided die. Or 6-sided die will be a 6-sided die. the die value holds. For example, if you roll a die, whatever value or whatever side it landed up is facing up is basically the die value. Roll basically creates a random object. We are creating a random number. For example, assuming the number of sides, assuming the number of sides of a die is 4, right? Assuming it's 4. Random.nextInt, we know by default without any parentheses. Random.nextInt, okay, without this, without any argument, gives you a range from 0 to whatever the size of an integer is. But if you type in a number, so number of sides, let me just take this away. Assuming number of sides was 4, I'm just going to type in 4 here. This is going to basically give you a random value in the range of 0 to 3. It doesn't give you a random value from 0 to 4. It gives you a random value in the range of 0 to 3, in the range of 0 to 1 less than the value you type here. Okay, so this is like the upper limit, but it's not included. All right, so if you type in 7, it gives you a range of 0 to 6. It doesn't give you a range of 0 to 7. What we did actually was we generated a random value. So let me just undo this and go back to where I was. Okay, so roll, we are basically generating a let's see, actually looks like, let me just make sure that this is correct, because it looks like this die class actually wasn't implemented correctly, because we have to add +1 here, just to make sure. But either way, we're going to get the value though. The reason why I'm saying that is because if we type in, hold on 1 second, let me just cross check a few things here. Hold on. File, open, and then let's go through the chapter 6 program just to see something here. All right, so I don't think it was this. Is it a game of 21? Yes. Okay, so this is the second program, a game of 21, where we use a die class. Let me just open this die class. All right, so the very first dice game, it was correct. I mean, it was correct. The program still worked with the, let's see. Okay, because we made copies of them, they all have the same question. All right, so this is actually, this +1 is actually the right thing to do. But then if you have a die class without the +1, it still works. The game is going to work, but then it's going to. So let me explain what the difference. All right, so let's use this die class then. Let's let's just add the +1. Take this away, and then let's just add. Oops. Open here. So 1 second. I don't want to confuse you or anything. So, programming challenges. Fission, game simulation. Here's our die. I'm just okay. So let me continue explaining. Right. So assuming number of sides was 4, this is going to go ahead and give us a range of 0 to 3, right? But basically, when we roll, we want to get, if the number of sides is 4, then we want to get the numbers 1, 2, 3, or 4, right? So if the number of we want to get 1, 2, 3, or 4. So basically, by adding +1 here, we are shifting the range. We are shifting the starting value for the range by 1, and we are shifting the ending value for the range by 1. In other words, we are shifting 0 to 1 and then 3 to 4. So by doing this, we are going to basically generate a random number from 1 to 4, and that's what we want, because the number of sides was 4, right? And once we roll, we want to get either 1 or 4, 1 or 2 or 3 or 4, basically any number from in the range of 1 to 4. So that's what we want, and that's why we need a +1. If we didn't have the +1, then this will give us a range from 0 to 3. Still works, right? If you still roll a die, you get a value from 0 to 3, but you wouldn't get 4, and you need 4. So that's probably that's basically what happened with the other die class. But again, the program still works. I'm sure maybe I actually edited the program, sometime but I'll have to take a look at it just to make sure. Yeah, but then it doesn't affect the program anyway. It doesn't affect the program in any way. When you still roll the die, you get numbers from 0 to 3. Okay, the only thing is you wouldn't, if you have a 4-sided die, you wouldn't get the fourth value. If you had a 6-sided die, you would get 0 to 5, and you wouldn't get the sixth value. So that's fine. I mean, sometimes you have a die and you roll it for 10 times and you never get to 6, right? So it makes sense. So the program, it doesn't affect the functionality of the program in a game of 21. It doesn't affect it. The only thing is, it's just like rolling a die and never getting the last value, right? Never getting the highest value, or 6, but you're getting anywhere from 0 to 5. 0 doesn't matter actually. It's just 0, right? But so basically, you understand. I hope you understand what I'm saying. All right. But for this one, we are doing it right. So, not that in the game of 21 we did it wrong. It's like I said, I explained, we are not getting the last value. All right, so that's why I put in the number of sites plus 1. Well, that's why there was a number of sites initially there. We just need to put in plus 1 here. So the number of sites is 4. 4 plus 1 is 5. It's just like typing 5 here, 5 here, and then plus 1. 5 here. 5 plus 1 is basically going to give us a range from, well, just 5 on its own, right? It's going to give us a range from 0 to 4. But if the die has 5 number of sides, okay, or basically it has 5 sides, then we want, the person rolls it, we want the value of 1, 2, 3, 4, and 5. Basically 1 to 5. So when we add plus 1 here, okay, we are shifting 0 to 1 and then 4 to 5, and so that means this is going to generate a random number anywhere from 1 to 5, and that's exactly what we want. So I'm going to change this to number of sides since that's a number of sides plus 1. All right, so that's what it's doing. That's what the roll method is doing. Making sure that I have closed this correctly. Yes, I think I actually modified it because I guess I can see I don't even have my closing curly brace for this. Yeah, so I'm sure I actually did it correctly in the game of 21. Maybe I modified the program and I ended up deleting it. Maybe I was explaining it actually. I guess I know what it is. I probably did the program, went back to the die class. I was explaining it, and I the way I was removing this, plus 1 and all that. Maybe I was doing that and I forgot to put it there. But then, yeah, I'm sure I explained it in the program, and then still people got it, and probably people saw that I forgot the plus 1. Anyway, I'm talking too much. Let me remove this, and all right. So now the die class rolls it and gets a die over here. That's what the roll method does. Get die value just returns the value of die 1. Okay, so whatever die value it is, it just returns the value so we can see it. It just returns it. And this is the constructor. Once you basically try to create an object from this class, you provide in a number of sites. It sets the number of sites filled to the number of sites that you just typed, okay, or you just provided to the die constructor, and it rolls it automatically. Okay, So as soon as you create an object from the class, that object has a die value. All right, so that's just a little bit. I guess it's probably good enough. But then if you want an in-depth explanation, just watch either the game of 21 or the dice game, and I think in one of them we actually fully implemented the die class, and one of them we just copied it. So just go through any of those programs and you'd see which one has the full implementation of the die class.